You're watching an unexpected visitor from deep space. Meet 3I Atlas, the third interstellar object ever spotted by human beings through the Atlas program. And Chinese scientists captured several incredible snapshots.
A new announcement has just come out of Beijing, and its timing alone has raised questions among those who've been tracking 3I Atlas. The update is brief, almost subtle, yet there's a tension in the wording that hints at something more beneath the surface. China has released new observations of the interstellar object, and while the report is written in technical language, it suggests that what they saw doesn't quite match the assumptions many scientists had grown comfortable repeating. The way the statement is phrased leads to one inevitable question. What exactly did China detect during those hours when the rest of the world wasn't watching? For months, telescopes around the globe had been locked onto this strange traveler, an icy, fast-moving visitor from beyond our solar system that refused to behave like any comet astronomers thought they understood. Even before China's announcement, the global scientific community sensed that 3I Atlas was about to challenge more than just existing comet theories. The closer experts looked, the more they encountered behaviors that clashed with long-held expectations. As these anomalies piled up, a quiet unease began to grow beneath the excitement, a feeling that this object might be pushing scientists toward redefining what interstellar visitors really are. China's report, though presented as routine, only strengthened that suspicion. Scientific monitoring of 3I Atlas became a coordinated global effort, combining the steady precision of ground-based observatories with the unmatched sensitivity of space telescopes. Hubble provided optical images. The James Webb Space Telescope analyzed its infrared signature. Observatories across Europe, South America, and the Pacific tracked changes in its brightness and motion. But from the very beginning, 3I Atlas refused to follow the script. Instead of brightening as it approached the sun, something nearly all comets do as their surface ice vaporizes, it barely released any water vapor at all. Its coma, the glowing cloud around it, was almost completely dry. Instead, the halo was dominated by carbon dioxide emissions, a chemical profile that suggested it formed under conditions very different from those that shaped the comets we know. This chemical oddity deepened the mystery. A CO2-driven comet is rare but still within the realm of possibility. But an interstellar comet powered almost entirely by CO2, with almost no trace of water. That was something far stranger. It hinted at a planetary system shaped by colder, more distant, or more volatile-rich processes than anything found in our own cosmic neighborhood. And just as scientists were beginning to piece together this puzzle, an unprecedented disruption hit the global network of observatories. Over a strangely overlapping 36-hour period, nearly every major Western telescope entered scheduled downtime. Hubble went into gyroscope recalibration. JWST switched modes, requiring more than a day to thermally stabilize. The Very Large Telescope in Chile started a maintenance cycle, its massive mirrors taken offline for cleaning. Gemini North and South moved to pre-approved programs that had nothing to do with monitoring transient objects. Individually, each of these actions made perfect sense. Taken together, their timing was almost impossible to ignore. Together, these overlapping shutdowns created something astronomers fear most, a global blind spot. And the timing could not have been worse. During those critical hours, 3I Atlas moved into its most revealing position, slipping dangerously close to the sun's glare, where observations are already notoriously difficult. Without specialized instruments watching, the object disappeared into the solar background. That missing window of data left a permanent gap in the light curve of an object that will never return to our solar system. For scientists, this wasn't just a missing data set. It was the erasure of an irreplaceable moment in a once-in-a-lifetime event. But the sky wasn't silent everywhere. Across the Pacific, China's high-altitude observatories in Tibet, Qinghai, and Yunnan kept their eyes on the object. Their schedules, unaffected by the downtime of Western institutions, remained fully active through the blackout. The thin, cold air at those elevations offered ideal observing conditions, giving China uninterrupted coverage at the exact moment the rest of the world was effectively blind. Automated telescope networks tracked the fast-moving object with impressive precision, adjusting in real time as weather and visibility shifted. While the larger, more powerful observatories paused, China's mid-sized instruments captured the only continuous stream of optical and infrared data during that crucial period. Their approach was technically meticulous. Short exposure times between 30 and 120 seconds were used to prevent motion blur as 3i Atlas raced across the sky at extraordinary speed. Each image was time-stamped with millisecond precision, using GPS-synced clocks and saved in FITS format, keeping essential details like filter settings, temperature, and pointing coordinates intact. The files were transmitted through fiber optic networks to fortified data centers in Nanjing and Beijing, where layers of redundancy ensured uninterrupted power even in harsh conditions. Engineers nicknamed these facilities servers under ice because of their remarkable reliability under extreme environments. By the time Hubble and JWST came back online, 3i Atlas had already moved but more than 1 million kilometers along its hyperbolic path. Without China's uninterrupted data stream, reacquiring the object might have required blind scanning and introduced significant uncertainty in its predicted position. Instead, China's observations helped preserve a seamless global timeline. What Chinese observatories recorded during the blackout only deepened the mystery. Across those 36 hours, 3i Atlas brightened by about 1/3 of a magnitude, a moderate but noticeable rise indicating a brief surge in activity. Its coma stretched in the direction of the sun, hinting that a jet of gelatin dust had erupted from the nucleus in a highly unusual direction. Later analysis showed that the dust grains released during this event were unusually large and rich in carbon, a combination rarely seen in comets from our own solar system. These subtle details pointed toward internal processes, or perhaps external influences, that didn't resemble anything comet researchers were used to. And although China's report held back from making bold claims, its careful wording made it clear that these implications weren't overlooked. In the weeks that followed, more anomalies appeared. Images taken in November 2025 revealed a teardrop-shaped extension of the coma, pointing toward the sun instead of away from it. Researchers quickly labeled it a sunward anti-tail, but the name raised more questions than answers. The structure's shape and stability led some scientists to suggest it might not be a simple dust feature at all, but possibly a collection of solid fragments or particles trailing or even loosely orbiting the main body of 3i Atlas. Because the nucleus seemed to be experiencing non-gravitational acceleration, likely from CO2-driven outgassing, any solid fragments not affected by that force would slowly fall behind, creating a feature that, from Earth's perspective, appeared to point sunward. The idea of a small swarm accompanying the comet was bold and controversial, but it emerged directly from the data, not speculation. Complicating things further, observers noticed signs of pulse jet activity, episodic bursts that caused the comet's brightness to rise and fall like a slow, steady heartbeat. If confirmed, these pulses would point to a rhythmic internal process, possibly linked to rotation or to the exposure of different CO2-rich patches on the comet's surface. Nothing like this had been observed in Oumuamua or Borisov, the only two interstellar visitors previously studied. Once again, China's dataset quietly contained the strongest clues, even though their official statements avoided dramatic interpretations. These findings carried implications far beyond 3i Atlas itself. For decades, the world's most powerful telescopes, mostly within Western institutions, had been seen as the primary gatekeepers of astronomical discovery. Their enormous size and peerless sensitivity made them the standard for cosmic truth. Yet, during the most critical moment of 3i Atlas's passage, those giants were silent. Instead, it was a distributed network of smaller, automated Chinese observatories that captured the defining dataset of this historic interstellar visitor. In this case, continuity proved more valuable than sheer aperture. Hundreds of short, precisely timed exposures, once stacked and processed with advanced algorithms, achieved signal-to-noise levels comparable to those from far larger telescopes. The event quietly shifted perceptions about who now holds the keys to major astronomical discoveries. When China eventually released its final consolidated analysis, the wording was cautious, verified, and completely free of sensationalism. The report confirmed the essentials. 3i Atlas was made mostly of carbon dioxide ice. It came from beyond our solar system, and it had already passed through ours on a one-time trajectory before disappearing back into interstellar space. But beneath these simple conclusions was a deeper message. In its final line, the report echoed an earlier poetic phrase: "Nothing about the object has changed, and yet everything has." It was less a statement about the comet itself and more a reflection on humanity's relationship with the universe and the systems we depend on to observe it. The cosmos doesn't pause for scheduled maintenance. It doesn't sync with our calendars or respect institutional hierarchies. It reveals its secrets only to those who are watching at exactly the right moment. During the crucial hours of 3i Atlas's closest pass, half the world's instruments looked away. The other half didn't. And in that brief window, the most important clues about this interstellar visitor were captured not by the biggest telescopes or the most advanced technology, but by the observatories that stayed awake when others went dark. In the end, China's report didn't uncover alien technologies, hidden threats, or dramatic revelations. What it revealed was far subtler and far more meaningful. It showed that the landscape of exploration is shifting, and that uncovering the truth about our universe is becoming a truly global effort. 3. iAtlas offered a short-lived message from another star system, whispered into the record during a moment when only a few were listening. It reminded us that the universe is porous, restless, and more interconnected than we imagine, and that sometimes the unsettling part isn't what we discover, but how close we came to missing it entirely.